Download this code from codegive.com, link in the description below. OK, let's dive into the merge intervals problem on LeetCode, problem number 56. This is a classic interval problem that tests your understanding of sorting, interval manipulation, and algorithm design. I'll provide a comprehensive explanation, covering the problem statement, the core idea, the algorithm, complexities, and a detailed code example, primarily in Python, but adaptable to other languages. Problem statement. Given a collection of intervals, merge all overlapping intervals. Example asterisk. Input, 1, 3, 2, 6, 8, 10, 15, 18. Output, 1, 6, 8, 10, 15, 18. Explanation, 1, 3 and 2, 6 overlap since 2 is within the range of 1, 3. They are merged into 1, 6. Input, 1, 4, 4, 5. Output, 1, 5. Explanation, 1, 4 and 4, 5 are considered overlapping. Core idea and strategy. The key idea is to 1. Sort the intervals sort the intervals based on their start times. This is crucial because it allows us to process the intervals in order and easily determine if consecutive intervals overlap. 2. Iterate and merge after sorting, we iterate through the sorted intervals. We maintain a merged list of intervals for each interval in the sorted list. If the current interval overlaps with the last interval in the merged list, we merge them. Overlapping means the start of the current interval is less than or equal to the end of the last interval in the merged list. The end of the merged interval becomes the maximum of the two ends. If the current interval does not overlap with the last interval in the merged list, we simply append the current interval to the merged list. Algorithm, step by step. 1. Input a list of intervals, where each interval is represented as a list or tuple of two integers, start, end. 2. Sort the intervals in ascending order based on their start times, the first element of each interval. Use a standard sorting algorithm, example sort in Python, arrays.sort in Java, etc. 3. Initialization create an empty list called merged_intervals, or similar. This will store the merged intervals. 4. Iteration iterate through the sorted intervals, one at a time. 5. Merging logic for each interval current_interval. Check for overlap if merged_intervals is not empty and the start of current_interval is less than or equal to the end of the last interval in merged_intervals. Merge update the end of the last interval in merged_intervals to be the maximum of its current end and the end of current_interval. Essentially, we're extending the existing interval to encompass the overlapping one. No overlap otherwise, if merged_intervals is empty or current_interval does not overlap. Append current_interval to merged_intervals. 6. Output return the merged_intervals list. Example walkthrough, using 1, 3, 2, 6, 8, 10, 15, 18. 1. Input 1, 3, 2, 6, 8, 10, 15, 18. 2. Sort 1, 3, 2, 6, 8, 10, 15, 18, already sorted in this example, but the algorithm requires it. 3. Initialization merged_intervals equals 4. Iteration interval 1, 3 merged_intervals is empty. Append 1, 3 to merged_intervals. Merged_intervals is now 1, 3. Interval 2, 6 *. Asterisk start of 2, 6, 2, equals end of 1, 3, 3. Yes. They overlap. Asterisk merge, the last interval in merged underscore intervals is 1, 3. Update its end to max, 3, 6, equals 6. Merged underscore intervals is now 1, 6. Asterisk interval 8, 10 asterisk. Asterisk start of 8, 10, 8, equals end of 1, 6, 6. No. They don't overlap. Asterisk append 8, 10 to merged underscore intervals. Merged underscore intervals is now 1, 6, 8, 10. Asterisk interval 15, 18 asterisk. Asterisk start of 15, 18, 15, equals end of 8, 10, 10? No. They don't overlap. Asterisk append 15, 18 to merged underscore intervals. Merged underscore intervals is now 1, 6, 8, 10, 15, 18. 5 output asterisk 1, 6, 8, 10, 15, 18. Code example, Python. Explanation of the code. Asterisk merge underscore intervals, function asterisk this is the main function that takes the list of intervals as input. Asterisk edge case handling asterisk if not intervals checks if the input list is empty. If it is, an empty list is returned. Asterisk sorting asterisk intervals dot sort, key equals lambda x, x0, sorts the intervals in place, using the start time, x0, as the sorting key. The lambda function is a concise way to define an anonymous function that extracts the start time for comparison. Without sorting, the algorithm will not work correctly. Asterisk merged underscore intervals equals asterisk initializes an empty list to store the merged intervals. Asterisk for interval in intervals asterisk iterates through the sorted intervals. Asterisk if not merged underscore intervals or interval 0 merged underscore intervals dash 1 colon asterisk this is the core overlap check. Asterisk not merged underscore intervals, if merged underscore intervals is empty, there's nothing to overlap with, so we add the current interval. Asterisk interval 0 merged underscore intervals dash 1, if the start of the current interval is greater than the end of the last interval in merged underscore intervals, there's no overlap. The current interval comes after the last merged interval. Asterisk merged underscore intervals dot append, interval, asterisk if there's no overlap, the current interval is appended to merged underscore intervals. Asterisk else asterisk this block executes if there is an overlap. Asterisk merged underscore intervals dash 1 equals max, merged underscore intervals dash 1, interval 1, asterisk this is the merging step. It updates the end time of the last interval in merged underscore intervals to be the maximum of its current end time and the end time of the current interval. This effectively extends the interval to cover both. We only need to update the end because we've already ensured that the intervals are sorted by start time, so the merged interval's start will be the earliest of the two overlapping intervals. Asterisk return merged underscore intervals asterisk returns the list of merged intervals. Time and space complexity. Asterisk time complexity, O, n log n, where n is the number of intervals. The dominant factor is the sorting step, intervals.sort, which typically has a time complexity of O, n log n, using efficient sorting algorithms like merge sort or quick sort. The iteration and merging take O, n, time, but it's dominated by the sorting. Asterisk space complexity, O, n, in the worst case. This is because in the worst case scenario where no intervals overlap, the merged underscore intervals list will contain all n intervals. In some implementations, Sorting can also take n space. If you can sort in place, the space complexity could be considered log n, for the recursion stack of sorting, or 1, if using an in-place sorting algorithm such as heap sort. However, the merged underscore intervals list will still need n, in the worst case. Important considerations and common mistakes. Asterisk sorting is essential. Asterisk forgetting to sort the intervals is a very common mistake. The algorithm relies entirely on the intervals being sorted by their start times. Asterisk in-place modification, optional. The code I provided modifies the merged underscore intervals list in place. If you need to preserve the original input intervals, you should create a copy of the input list before sorting and merging. Asterisk edge cases. Asterisk always consider edge cases like asterisk empty input list, asterisk list with only one interval, asterisk intervals that are already merged, example 1,5, 2,4. Asterisk overlap definition. Asterisk make sure you understand what constitutes an overlap. In this problem, 1,4 and 4,5 are considered overlapping because the end of the first interval, 4, is equal to the start of the second interval, 4. Asterisk understanding the merging logic. Asterisk the merging logic, merged underscore intervals dash 1 equals max, is crucial. It ensures that the merged interval covers the entire range of both overlapping intervals. Adaptation to other languages, Java example. Here's how you can adapt the Python code to Java. Key differences in Java. Asterisk interval class. Asterisk we define a simple interval class to represent the start and end times of an interval. Asterisk comparator. Comparing int. Asterisk we use comparator. Comparing int, to sort the intervals based on their start times. Asterisk ArrayList. Asterisk we use ArrayList to store the intervals. Asterisk math.max. Asterisk use math.max, to find the maximum of two integers. This explanation should give you a strong understanding of the merge intervals problem. Remember to practice implementing it, consider edge cases, and understand the complexities involved. Good luck.